So today we're going to talk about classes. And this is the assignment page, and it's the last assignment of the quarter. You need to create something called a rectangle class, and for exercise 2, a number class. Now these classes are data types. So you have a number class that has that name, number. And then you can create an instance of that data type. Usually we precede a variable name with the data type. So the variable name here is 9. And I'm using lowercase to begin the variable name with. That's a convention. And the class name starts with an uppercase letter. That's also a convention. It's not required by the language. It's just a typical naming convention that programmers follow for C++. So we have the data type followed by the name of a variable. And then we have these parentheses. It looks like a function call. So we're passing in information that specifies how the data type, how this instance of the number class is to be initialized. So we have a data type that represents numbers. We already have a data type for numbers. We have a double, that's a floating point. Those are used to represent floating point numbers, int to represent ints. So this number class is yet another data type to represent numbers, in this case integers. Maybe I should have called this class integer. That would have been better. So we pass in an integer here. And then once we have an instance of this data type, in this case we call it 9, down here we create another instance, and I'm just calling it 7 because I'm passing a 7 in as initial data. That once we have these instances, we can call functions on them using this dot operator. So it's 9 dot is prime, open close parentheses. That right there is a function invocation. So rather than passing the value into the isPrime function, the isPrime function works on the data that's contained in that instance, 9, the 9 instance. So isPrime here returns true or false, and then we, and then we reverse the value with this not operator. So if isPrime returns, let's just look at this. 9 is not prime, right? 9 is not prime. So what I have highlighted right here should evaluate to false. And then we use the not operator to convert false to true. So this expression evaluates to true. So we're passing true into the assert function. So nothing happens. We just pass right through that statement, and then we do the next one. And the next statement that we evaluate is also an assert statement. And we evaluate this expression, 9 dot is divisible by 1. We evaluate that expression and pass the result into the assert function. Is 9 divisible by 1? Yes. So that expression should evaluate to true through passing true to assert. 9 is divisible by 2. Is 9 divisible by 2? No. So that sub-expression should evaluate to false. So we expect it to be false. So we toggle that state. We reverse it with the not operator, so to convert the false to true, because we want the assertion to succeed. So these are the test cases. This is just an example of test cases. And in the test cases, you can see how to call these functions with the dot operator. We've already seen this already with vector class. You know, the vector is a class, actually. So we have a vector v, and we can do v dot size, v dot pushback, like that. That's called the dot operator. And this is not unique to C++. This is the common syntax that's used by most languages now. You have a class, like if you're in Java or C#, TypeScript, all these different languages, they all have this notion of a class. And you create instances of the class, and then you invoke class functionality with this dot operator, calling functions against instances of the class. So in this case, in exercise 2, you need to split up your code across 3 files. There's the file that has the main function in it. There's a header file that declares the number class. And then there's an implementation file that provides the statements that comprise the functions in the class. And in the first exercise, you don't need to split it into 3 separate files. You just put everything in one file. See, there's different ways of organizing code. So for this particular assignment, you can look at 2 different ways of organizing code. In the case of exercise 1, we put everything in one file. We'll see what it looks like in that case. In exercise 2, we spread the code out across 3 files. See how that looks. All right, so let's look at an example. Let's do something from scratch. Here's a main function. You can see here that vector is a class. We have the data type, and we have the variable name. Once we get the variable name, we can invoke functions with the dot operator on that variable. V dot size. This is actually the I forget what the operator name is, maybe the index operator. That's actually also a function. I'm going to prove that to you. See what I just had, this is an alternative expression. So this is the same as this. This expression here is the same as that expression, I think. Let me try it. I got it. So actually, this is how the function, this index operator is defined. That's how it looks. But the language allows us, that when you define the operator like this, then you can also use it in this in that syntax. So this looks like a function that's being invoked through the dot operator. That's the point I'm trying to make there. All right. Let's let's define a class and then use it. And I thought of a class just a second ago. What is it? I'm trying to remember here. It's like something, oh yeah, bean jar. I've used this example before. So we have a class called a bean jar. It'll represent jars to contain beans. So look at that semicolon right there. That's necessary, just so don't forget that. The compiler these days is pretty smart to warn about that missing semicolon if you happen to miss that. So you start with the word class, followed by the name of the class, open brace, close brace, semicolon. That's the outer shell of the class declaration. Normally you have a public section and a private section. The public section is member variables and functions that are visible to the outside. The private section declares member variables and member functions that are only visible internal to the class. Now the bean jar is going to contain, we're going to have different size bean jars. We want to represent different size bean jars with this data type. Okay, so we're modeling bean jars here. So we'll have a variable that represents the capacity. How many beans are in the bean jar? Can we put in there? What's the capacity in terms of number of beans? And we'll have another variable, we'll call it beans. That's how many beans are currently in the jar. So, it must be that, beans must be less than or equal to the capacity, for sure. That's a requirement. So we put these variables in this private section because we want to, basically this is just our internal way of doing accounting in our data type. We don't want these visible to the outside directly. We just want to keep them as hidden data. So what's visible to the outside is what we want to, we're going to provide restricted access to this, to the state of the data type here. And so we'll just open up whatever functionality we want outside code to be able to invoke. Well, one thing that we need is what's called a constructor. And the constructor is a function that is called when an instance of the data type is created. And it's the constructor's job to initialize that instance. So we have two member variables. Capacity, we'll initialize it to 0, say, and beans, initialize that to 0. And so now we can actually create an instance of this bean jar. Call that J1, jar 1, jar 1. That's it. Let's see if that builds. Oh no, actually this is a little funny. If we have, for class instances, when we call the constructor, we don't use parentheses if we pass no information. It's kind of an anomaly in the language, actually. All the other newer languages don't have this requirement. A newer language you would use that syntax to create an instance of a data type using a constructor that has no arguments. Yeah.
Why do we have a semicolon after the brackets?
The semicolon where?
On 16. Yes, 16.
That's required, actually. That's another unfortunate aspect of the language. The languages aren't going to require that statement termination symbol like it does in C++. That's required.
Well, when is it required specifically?
The compiler doesn't know when the class definition is ended. There's some ambiguity in the way the language is defined. There, you can create a situation where the omission of that semicolon creates an ambiguity. I can't produce that for you, but that's my understanding. C++ has a number of weaknesses because it's an early language that uses classes. It's one of the first languages. It's not the first. But it's one of the first languages that uses classes. And what happened was that there's this guy named Bjarne Stroustrup, and he defined the language. And what he did was he defined it in such a way that the C language, which is very popular and widely used, is defined as a subset of C++. So I think that restriction there, that need, that requirement, caused some difficulties in defining the language nicely. So you had, after C++, given another language called Java. And Java is like an improved C++. So a lot of these unfortunate syntax requirements have been eliminated, like that semicolon, you don't need that. And no argument constructor would be invoked like that, Java. And then after Java came C#, and C# is an improved Java. So I saw those three languages evolve.
What do you think the best object-oriented language out there right now is?
Well, I can only report on my experience, and I would say the easiest to code big applications very quickly is C#. But I think it depends on what you're doing, and I haven't seen all the languages. But C# using Visual Studio is really fast. Okay. And so anyway, this is running. Let's add some functionality, and we'll test it with assertions. Now, before we do that, let's print things out. We have this jar1. And let's do something like get beans. How many beans are in the jar? So that's a function we need to add. So when the function is called getBeans, it returns an int. So that's the return value declared there. And all it does is it just returns beans, which is this private variable. Now, getBeans, the function getBeans is defined here in a public section. So code on the outside, like this code right here, can access getBeans. You can call getBeans. And that's how we get at the data inside the class. We have some restricted access to the state of these instances. Now, let's see if that works. I'll test, there's the 0 right there. In fact, you can turn that into an assertion. Assert getBeans equals 0. There it is. Now, we cannot do the following. We can't go jar1.beans. We can't do this because beans is a private member variable of the bean jar class. And we'll have a compilation error. There it is. Error. Beans is private. You see that? Beans is private. Of course, if we made it public, we wouldn't get that error message. Now it works. But normally, you can do this. You can make the member variables public. Then we don't even need this. We don't need this anymore. But the style that is common is to hide the member variables. I'm going to show you the common style. It's not necessarily the style you have to stick to, but it's a style that you'll see usually in code. The normal style is to hide these member variables and provide these functions to access or operate on the data. So this is called a getter method. The reason for this style is it's supposed to allow you to restrict what can be done with the data in the class. So here, we can't change beans. We can't do this. We can't assign a value to beans in jar 1. See, so because we've limited what can be done with these bean jar instances, we can't change the value of how many beans they represent. So we try to do it like this, we're going to get stopped by the compiler. There it is. Beans is private. Anyway, that's the reason for that. If we wanted to be able to set the beans, then we'll use what's called a setter method. Excuse me. So we have this called a setter method, and this is the typical name for it, set beans. We want to pass the beans in here, B. And then we take the beans that are stored inside this instance, we set it to the value being passed into the function. That's called a setter. So we would do something like the following. We'll set the beans to 3. And then we assert that get beans now returns a 3. To get this, you gotta play with it like I'm doing, right? I'm like practicing up here. Like I'm playing the violin, and I'm just keeping in shape. But that's what you have to do. You gotta just practice this stuff. You just have to practice it like you're practicing a violin. You just try to do it every day if you can. Well, unless you don't expect to be doing this in the future, of course. But this is a really common thing for entry-level graduates of our computing programs to do. They get hired to write code. So to get that job, to get that first job, you got to practice and be competent. So you need to practice. You don't have to stay in the job for the rest of your life. You can switch, but it's good for getting that first position. It's not guaranteed though, but it's a typical way that graduates have gotten into the workforce here. All right, so let's see. we've got these get beans and set beans. I'm going to show you some new stuff here. This get beans, we can declare it as const because it doesn't modify the state of the data instance. See that? So I'm going to compile, no problem. But if I declare set beans as const, we're going to have trouble because look, we're changing the state of a member variable through assignment here. So the compiler will flag that and refuse to compile. Error, assignment of member beans in read-only object. Beans equals B. So we can't, and it's good practice to declare functions as const when they're meant to be constant. When they're meant to be only like provide read-only information so that calling them doesn't modify the state of the object. By the way, I've been using the word instance a lot, this data type instance. Another word that's used to talk about that, to talk about these things, is object. This is an object. An object is an instance of a class. You have one class, and it's used to create many objects. Right? So you can think of objects as being many, and the class is just one thing. The class is like a pattern, a template, out of which you create these objects, these instances. Now, the set beans, a pattern that you frequently see, and which I follow, of course, not of course, but I like to follow this, is this setter method is just going to, the parameter name, I want to make it identical to the member variable name because it's like a form of documentation. I know where this thing is meant to go. But the problem is we have an ambiguity because this variable here, this piece of data, which is named here, is different than this piece of data that's named here, but they have the same name. It's like there's two Sams in the class right now, right? And if I say, hi, Sam, you don't know which Sam it is, right? But if it's Sam Jones, and I say Sam Jones, and we know that Sam knows who he is. So just like that, we need to give the compiler a little information to distinguish between these two data items. The data on the right-hand side is the parameter beans. The data on the left-hand side is meant to be the member variable beans. The parameter beans has more narrow scope than the member variable beans. And so the parameter beans overshadows the beans, the member variable beans that has broader scope. So we need to qualify the use of member variable beans. So we use this dash greater than. That looks like an arrow here. So this is a way to tell the compiler that this beans here is the member variable beans. I want to set that to the value that's being passed into the function. Remember, I warned you about classes. This is going to be hard, right? Remember I said that? I mean, I got to tell you right now, this is trivial for me. I mean, it's absolutely like super trivial, but you got to practice this over and over and think about it, and it'll become trivial to you. I mean, it's just like, for me, it's like breathing. It's like I can do this in my sleep, and half of you are sleeping right now. Sorry about that. But I just want to say that, I'm the one that's up here practicing this thing, and I don't need to practice. You're the one that needs to practice. You just got to do this. You got to practice this. And in the beginning, you're going to say, I don't know, I don't get it. I don't even understand it. Why how can I even practice? I don't know. You just got to get started. Do some experiments and break in there. Did you have a comment, anybody? No.
I'm getting an error. Let's see what I did wrong.
Let's take a look. And how can I? Give me a few letters in your ID.
ID? The number thing?
Just a few letters that are in your ID, so I can find you.
Let me see. AHMAD.
AHM. That one? That one?
No. Keep going. AD.
Not ED, right? There it is. AHM, and I matched 3 different accounts. Can you believe it? All right.
I would believe that there are like 6 or 7 people in my family with the same name. I mean, you say Ahmed in
In
my
one family.
Yeah, you say Ahmed in my family,
Yeah.
like 5 people are gonna go like, who? I mean, my grandfather died while my uncles were young, so they all named after him.
There's a Dr. Seuss story about 37 Daves. Does anyone know that? Nobody? Oh, nobody's a parent yet. That's incredible. That's a very interesting story.
That was a big family, though.
They all have the same, 6 or 7 of them have the same. Your name?
Yeah,
Your name.
My name. They named me after my grandfather, so I mean.
And then if your grandfather's
they died
around, you
when
got
they
more
were young,
confusion.
So they had a reason to do that, but
Yeah.
they all did the same thing. So.
That is amazing. All right, so which file is it?
Open class.
Okay.
There's just one.
Let's see, does it show anything? So this is a syntax error.
I tried to follow exactly what you did,
Yeah.
but
The capacity on public and private are different, spelled differently.
Yeah, now what I want to do here, watch this. I indented this. I didn't used to do that in the past, but I'm doing it this quarter. That's all inside the public section there. That makes it a little easier to read, perhaps, okay? Oh yeah, you're declaring capacity here. You should only declare capacity once. Do you see the problem? Can you fix that?
so I shouldn't declare it the first time.
This is the first time. This is where you declare it. I mean by first. Also, this isn't spelled right. That should be an S and C, right, capacity.
Oh, all right, I'll do it.
That
Thank
works,
you.
right?
Yeah, it works.
Why don't you use instead of B here, why don't you change this to beans? Set beans, pass in the name beans. See, because it's meant to go into beans, so we'll just use exactly the same name.
All right, so if I do int beans, do I have to say beans equal beans down? Or
Yeah,
just beans equal?
yeah. Except the first beans is the member variable beans, so you need to use that trick to distinguish it from the parameter beans.
So should I do like this or?
Yeah, that's good. That's good. Now the left-hand side of the assignment is the member variable beans.
What's the difference between the left and the right?
So the right, this is the value that's getting passed in,
Right.
and you want the internal data. You want to set it to the value being passed in. So this name here represents the internal data beans. But because they had the same name, there's 2 Ahmeds in this family. So there's 2 beans in this family.
All right, so.
Now you got to identify. This is the Ahmed that's like closest to you. But you want the Ahmed that's farther away.
So I set them both equal each other.
No. You have to qualify this beans here with this arrow.
All right. It's a little confusing because they both have the same.
That's why I'm doing it with you here. Because every single person is confused right now. Okay, every single person. Can you put a this arrow in front of the left-hand side beans?
So you mean like this?
No. In front of it, not after it. Yeah, there. Now this, first this, no THIS, no bracket. No bracket, no angle bracket there. No less than symbol. There you go, this. And then right after the S, without a space, put a minus sign. And then a greater than symbol. Doesn't that look like an arrow? Not the other way. Yeah, there you go. Now I gotta tell you, this, the word this, is actually what's called a pointer, for those who know about pointers. And we're not gonna get into pointers beyond what I'm gonna say right now. This is a sort of a built-in keyword, and it represents a pointer to the object that the function is running against. A pointer is very simple. A pointer is simply the memory address of the data. So this, an instance of this object is sitting in RAM. And you got 8 gigabytes of RAM, 16 gigabytes of RAM. And each byte in RAM has a number. There's byte 0, byte 1, byte 2, you know, all the way up to 16 gigabyte value. So each byte has a number. So you can go sequentially. Then you have, so the object can be referenced in memory, in RAM, using that number. And this is that number for this object. And so once you have that pointer, it's called a pointer. Memory address. Once you have this memory address, you can access the data that it points to using this arrow symbol. Yeah.
How did you add those on the left-hand side, the purple lines there? How did you add that? The lines on the left?
Oh, I don't know. I don't know. I don't know.
This came with the indentation. When you indented the whole thing, they just appeared.
Oh, maybe those are, oh, I see. So let me save it here. And if I close it and open it, still got them. All right. I don't know why. What if I did this? You know, I get a line. Those are tabs. So I don't get it.
When I do a tab, I don't get that. That's interesting.
Maybe it's because it's my edits show up.
Yeah.
Oh, look, these are my edits. See, they get a underline. So I inserted a tab here. That's why it's underlining my inserted tab. So that's what, so you can see my edits. Yeah, neat. Thank you for that question. All right, let's go back to here. Now, these functions are being defined inside this class. But there's another way to do it, which is more sort of typical. And I want to show that to you. Rather than defining getBeans right inside here, we just declare getBeans using this style here. So int getBeans const semicolon. There's no implementation. There's no curly brace there with the commands inside there. We're going to put that outside this declaration block. See this block right here? This just declares what the class looks like to the outside. It also declares the member member variables too. So getBeans returns an int, and it takes no arguments. It's a const, and we simply return beans. That's what we had before. But the problem is, to the compiler, this just looks like an ordinary function. We have to tell the compiler that this function that we're implementing here is a member of this beanjar class. We do that using the name of the class followed by 2 colons.
I'm sorry, can you repeat what that does?
So we need to the function, if it looks just like this, the compiler looks at it as just a function, a standalone function. But we want to tell it that this is the function that we're implementing here is the member function of the beanjar class. So we use the name of the class followed by 2 colons in front of the function name. Let's do the same thing with setBeans. I should have got the rest of it there. There it is, get beans and set beans. So both ways of organizing the code are valid. It's the same with the constructor. We can move the constructor down there as well. Let's do that. I'll put it here. The constructor is to define a constructor. What you need to do is define a constructor as a function that has the same name as the class itself. If the class name is beanjar, the constructor function must be called beanjar. The other thing about constructor functions is we don't declare them as having a return type. So notice I didn't declare this as void. And let's fix that up here. Here's the constructor, the get beans, the set beans, then we have these member variables. Let's try it. The constructor has a different format that's possible to it. This capacity could be set like this. You know what, let me do it like this. Oops. How do I comment that? Control slash, there it is. Or command slash. So this, there's another way to define a constructor here. I can use an initialization list. The capacity is being initialized to 0. Beans is being initialized to 0. Oops, sorry. So we have, following the name of the constructor here, we have a colon. We have an initialization list. It just has the name of the member variable followed by parentheses that are used to initialize, with data in it, used to initialize the member variables. These are actually constructors. This is like, you can think of this as a constructor. We're invoking the constructor for an int. And if this was, you know, a class, like the number class we looked at before, this would call the number class constructor passing a 0. And so that's that. Let's check it. Now, normally this is called a default constructor, but a no argument constructor. Maybe we want a constructor that where we pass in the capacity and the initial number of beans that are in the jar, rather than creating a jar that's initially empty with no capacity, because we can't set the capacity actually. It doesn't make sense. This constructor doesn't really make sense, does it? Setting things to 0 here. So I'm going to get rid of that actually, because it doesn't make sense. Not a good. Well, we could leave it in there if we like, and maybe give the capacity something like I don't know, 100 as a default. It's a jar with a capacity of 0. It doesn't make any sense unless we can say set the capacity. So okay, we're almost done. So we've got another constructor to implement here. So we have a constructor that takes an initial capacity and an initial beans. So here, this default constructor, the no argument constructor, we're going to just set the capacity to 100 so that it makes sense. For this constructor that takes the initial data like this, we can set it just like in a setter method. Once again, just like the setter method, we have this naming conflict here. So on the left-hand side, we want this to be the member variable capacity. I set that to the capacity that's being passed into the constructor function. There we go. So now, let's create a jar that has a capacity of 50 and 10 beans in it. So get beans now should return 10. If we set beans to 30, get beans should return 30. Now, I'm just going to do this a little differently from how I've done it in the past. You know, when we set beans, we can't have beans to be greater than the capacity. So we can use an assertion there. Make sure that beans being passed into set beans does not exceed the capacity. So if we have code that accidentally sets that, say, to something too large, we'll get a failed assertion. What else am I going to do? And they'll do the same thing here. So I want to show you how this looks in this alternative syntax. Instead of this syntax, let's use this syntax. So we have that initialization list. Now, the capacity, the compiler knows that in this initialization list, that name there is a member variable capacity. We don't need to say this there, right? Because that doesn't make any sense to the compiler. So it'll only allow in the initialization list this name to be a member variable. But what goes in here is, in this case, a constant, but actually what we want is for the parameter capacity to be used. So that's what it looks like. So we can't, the compiler knows that this is not going to be a member variable, it must be a parameter, so we don't need to qualify. I suppose there was, you know, a baby named Ahmed in your family, right? And then you as the grown person, and your father says, Ahmed, take out the garbage, right? Bring it out to the street. I don't know if you do that over there, but, and you know it's not the baby, because the baby can't take the garbage out, right? So in that context, the compiler knows that this capacity is must be the member variable, because it doesn't make sense to use the function parameter there. And likewise, this must be the function parameter, because it doesn't make sense for the member variable to be used there. So sometimes when you use a name in the context like this, the compiler understands what you want. But in this case, it's not the case. We have to tell the compiler how to distinguish the, between the two names.
So for the capacity then in brackets capacity, I mean in parentheses capacity. The first capacity refers to capacity and the function, right?
In the member variable. That one. In the member of the class. Because that's what the function, this constructor function is initializing these two variables. That's the purpose of the constructor, is initialize the member data, the internal data. So that internal data is on the left-hand side of those parentheses. So one last thing to do, at least I think there's only one thing to do. By the way, this formulation here is actually better than this one. Why did that work? That should fail because it should be duplicate definitions. Yeah. So we got duplicates there. I believe these are actually better. To use initialization lists are more efficient in some cases. If these get too long, you can just drop them down to the next line. However you want to do that. All right, so now what I want to do is show you how to break it into 3 files. So I'm going to copy main to beanjar, that's CPP. This is the implementation, the file that contains the implementation code for the functions. And then we need what's called a header file. So we've created these 3 things. Now the header file is just that class declaration without the implementation. That's what the header file looks like. But you know, header files can include other header files, so we want to avoid circular includes. So we just use pragma 1. Tell the compiler, hey, we don't want circular includes. It's kind of silly. I don't think anybody needs circular includes, but we have to tell the compiler not to do that. This is the new way to do it. There's an older way that you might have come across sometimes. Yeah.
When do we use pragma once?
When in all header files, .h. Because it tells the compiler you don't want circular includes. Like if it's processing what's called a compilation unit, and it finds an include directive. It says include beanjar.h, but it says, oh, wait a minute, I already included that via another mechanism. So it says pragma 1, so I don't need to include it again. Now the CPP file is the function implementations. Main is not part of the class, by the way. Main is the outside code. So in the implementation, we're using assert here, so we need to use that header. But actually, we also need the definition of the beanjar class itself, so we need the beanjar header file. Now this is case sensitive. Well, it depends on the operating system, right? No, Windows, it's not case sensitive. So by convention, you don't have to use the same name as the class name, but it's a helpful convention. The header file is the same name as the class. The implementation file has the same name as the class. That's just a helpful convention that is generally followed. Now main needs to include that beanjar header file as well. So that means this whole thing is brought in through that includes directive. So we don't need that. Also, these function definitions are compiled using in a different what's called compilation unit. These files that end with .cpp are called compilation units, and they're compiled on their own. So this main.cpp is compiled on its own. And then beanjar.cpp is compiled on its own. And then the results of those two separate compilations are then hooked together through what's called a linker. So the linking is done at the end. That's how a big project is compiled. And think about it, you can have a program with tens of thousands of lines of code. And you don't want to compile everything all at once. It could take a long time. 1 million lines of code, that might take an hour to compile. So if you just change one little piece of it, you don't want to have to recompile everything. So you change one little piece, the compiler just compiles that one changed compilation unit and relinks again. That speeds up compilation. It speeds up development time. So now when we build this thing, we have to list all compilation units on the command line, tell the compiler to operate on all compilation units that the program depends on. So if we leave one out, it means the compiler will only compile main.cpp, but it will not compile beanjar.cpp. So the compilation succeeds, but the linking phase fails because it's looking for, when we call get beans here in main, it goes, okay, I've got to find where get beans is, but it can't find it because we didn't compile that compilation unit. There it is. See this LD in there somewhere, right? LD returned 1 exit status. It should return a 0. That means success. LD is the linker on a Unix system. So remember that. You have to use both CPPs on the command line. How is that? That's everything. That's the whole picture that you need. Oh, one more thing. Sorry. The UML class diagram. Let's just do this really quickly. It's not hard. It's the easy part. These classes are hard to sort of understand or visualize. And so what people sometimes do is create diagrams to give a bird's eye view of the class. One such diagram is called a UML Class Diagram. Class diagram looks like this, has 3 sections. The top section, it's got the name of the class in it. The second section has the member variables in it. If they're private, we start it with a minus. Capacity, and the data type is followed. It's a little different. We don't precede the variable name with the data type. We follow the variable name by the data type. And then we have beans. This just gives you a way to look at the class, you know, from I guess a bird's eye view, we call it. And we have the constructors down here. And these are public, so we push we use a plus sign. These are not just constructors, but all functions. So bean jar takes capacity, which is an int. This is just documentation I'm showing you now. And then there is beans, which is an int. And then we have set beans. Set beans is a void. Set beans takes beans, which is, see the data type is sort of indicated differently. We use a colon and followed by the data type. It's just the way UML class diagrams are drawn up. We have get beans. Get beans takes no argument, but it has a return type, which is then listed here. I think that's it, right? We can add more functions to this class. We'll do that next time. That's the UML class diagram. All right, that's it. We'll see you next time. From this point on, it's a review of the material I presented today, and also a review of other material that will appear on the final.